So sorry guys, in this second tutorial I want to take out time and explain properly this boost algorithm. So look closely and now watch how the bits are positioned. So the first one takes the LSB B0. Now for the second one, you can see they are more like a repeated set of circuits. So when you go through them, you see that they are obviously the same repeated circuits. So the first one compares LSB B0, next one will compare bit 0 and bit 1, next one will compare bit 1 and bit 2, next one compares bit 2 and bit 3, then another one compares bit 3 and bit 4, bit 4 and bit 5, bit 5 and bit 6, bit 6 and bit 7. So you stop at 7 because you actually started from 0. So say from 0, since there are 8 bits total, so depending on the total number of bits will determine how long you do it. So since the inputs are 8 bits, you do it from 0 to 7. So what it actually does, just like I gave in this notepad here, these are the, so just assume you didn't see this. If you have 1 1 1 1 means if the two are on, the value will be 0. Now let me give you an instance here of when the two are 1 1. Now if this is on, that is if the first bit is on, that means you do this, then this one is also on, then it will give us 0. So this 0 is looped out through all the different segments of the circuit. Then again, if it's 0 0, if it's 0 0, then that means that is the two bits are off. This one is off, that means you go to this multiplexer, and this one is off too, that means you go here, then you still give us 0. So that is exactly what happens here. Then again, if you have 0 1, 0 and 1, give us the actual value of x. So 0 and 1, now 0 means off, so if this one is off, that means you go here, and 1 means on, so if this one is on, you go here, giving us the actual value of this input here, that is 0 1. Then when it's 1 and 0, 1 and 0, let's see, that is this one is on 1, that means you are going to this multiplexer, then this one is off, you are going here, then give us negative value of x. So this block is actually a negator, so it will give us the negative value of x in 2's complement. So that's how it works from this circuit. I think that is exactly what I explained here. If it's 0 1, you give us the value of x. If it's 1 0, you give us the value of negative x. If it's 1 1, you give us 0. Then at the end of the day, you add them slanting this way, so don't keep them together on same line like the way you do your normal addition. So for this is where it was actually implemented. Let me show you. So you now use an adder. So all these are adders, all these ones are adders which I used to add their final output at the end of the day. But there's a very important thing for the reason of this slanting. Now let me show you how it was implemented in the circuit. So this is it here. The first one, you take it as it is. This second one, you append 1 0 to it. This next one, you append 2 zeros. Here you append 3 zeros. Here 4 zeros, 5 zeros, 6 zeros, 7 zeros before you do the addition. That is What I mean by appending 0 means here you append 1 0, here you append 2 zeros, here you append 3 zeros, here you append 4 zeros. So that is how the boost algorithm was implemented for this circuit. So this is all what it looks like. So knowing fully well